Hi everyone and welcome to the second video of this series of tutorial. In this video we are going to learn how to make the type 2 of a wire netting using geometry nodes in Blender. So let's get started. We are in Blender 3.3.0 and we start with nothing in the scene. We have to go to plus, general and geometry nodes, shift A to add a mesh, a simple mesh, a plane, it's okay, and click new to generate a new geometry node system. Control right button, drag to unlink the geometry input to geometry output. So the basic concept of this tutorial is this. We have to create a wire like this, so rounds and rounds and rounds and rounds and so on, rounds and rounds from the other side, other round and so on. To do this part I tried many methods, but at the end I followed the basic divide impera method. So you have a big problem, well, subdivide in sub-problem. So this is the sub-problem, it's another big problem, so divide this in sub-problem. So I need to start with this simple problem. So one line in 45 degrees and a spiral. Then we will use this as an instance up in this direction to make this, and in a distance here. Then we will instance this with a mirror effect to have this and this, and then we will use this as an instance to this direction to have the opposite effect and finish the shape. So I hide the annotation for now, and the first part is make a curved line. Press 3 for right orthographic view, shift alt click to isolate the selection, and we have a curve that we want to go in this direction, 45. So I can simply indicate the start point at 1 meter here and 1 meter up. In a real environment we don't have 1 meter of this section line, so to make this more realistic I'll use 0.05 meter, so 5 centimeter and 0.05. We can call it the whole edge, and we can export this value, so use a combine XYZ, link Y and the vector here, 0.05 here, and duplicate this, link this value to the Z axis, and this is our segment. Shift right button drag to create this. Rename the Y as whole edge from 0 to 1 meter. It's enough. Save your project. Now, second part of the sub-problem, create a spiral. So before this, I can select this node, Ctrl J, linear part. Now we have a linear part, and we have to create the spiral, the second part of our instance. So we can join it together with the Shift Ctrl click, and you can see the spiral is very big. So we have to transform this and shift up where? To the end of this segment. This segment is up by this value, so the whole edge value. So we can create a combine XYZ, link this value to the Z, and link this vector to translation of this transform value, and we have the spiral translated. Now that we have moved the spiral on the space to the Z-axis, we need to normalize this information. So set this to 1 and 1 to see the result. So we mute for a moment this node with M, and we can see that in this space we have 1 meter of height. We have an entire period. So this means that if we want to have 45 degrees here, we have to increase the height with what values? So I can go here, so this is similar to 45 degrees, but if I look this, it's exactly 2 multiplied by, this is the correct value. So the relationship between the radius and the height is this. I have a radius so I can set these, rename these in radius, shift drag, set these at the end of the radius at the same time, and multiply this value by to multiply pi and use it for the height. I can shift and right drag to maintain this relationship, and you can see now if I decrease the radius, you always have the shape with an initial angle of 45 degrees. This is what we want always, because to the final shape we want the segment with 45 degrees around, and we want the line goes in the opposite direction always to 45 degrees. And if I add another round, we always want to have an entire period and then again 45 degrees to let the linear curve goes to the opposite side. To do this, you can see we have an entire period here, so an entire resolution, plus half of an entire resolution, so 0.5 value. So we can decrease a little bit the shape thanks to this radius, and now we have to shift this spiral and we have to select only this portion. So we already have the relationship between the radius and the height. Now we have to create the relationship between rotations and radius with the information described before. So we can use the rotation here, rename in rounds. This is an integer value from 1 to 100, I think. Set this to 1 round. Now we can simply subtract 0.5 and use it as the rotation to get only this portion. So if I increase, I always have this point following this direction, but I have to adjust the height. So I need a relationship between the rounds and the height. So if I have 1 round, I have these, I can just multiply these two values and link to the height to get the correct height based by this coefficient. So if I have 1 round, I have only a portion of the entire period. If I increase the round, I have 3 pieces. If I increase, I have 5 pieces, and so on, maintaining the correct proportional values between rotations, radius and height. Now we have the spiral shape, so we can select all these nodes, Ctrl J, F2, spiral part, save the project. Now we can decrease the radius 0.005. We can decrease a little bit, so use 2 for example. Now that we have this geometry, we have to instance this geometry in this direction to have this behavior. So we have to instance each 2 times this height. So if this is h, we want to instance on a curve with points of 2 multiply h. So this height is equal to the height of this line plus this height of our spiral. So this is very simple. We can add curve line, this is the line. We can instance on point this geometry, but we have to resample this curve by a value. What value? So I have to set not counts but length, and we can duplicate this group input, and we have the whole edge, but we also need the height of the spiral. So we need to get this value of the height and have to add what? The whole edge and link these to the length, but with a multiply by 2, and voila, this is the result. Now we can export the entire height of this curve to better manipulate the entire grid. So I can use a combine XYZ link here and export the Z-axis, rename it in height from 0 to 100, for example. Move these up. We can move the resolution up. We can also export the resolution of the spiral to let us have not too much points or faces for the final shape, and to get a better performance if you have a problem with your PC. Move the resolution up, shift drag, right button drag, G to move, and this is perfect. Now you can see I have to set 1 meter, for example, but you can see that if I decrease this value, I have this weird effect. So the length, I don't know why Blender does this strange behavior, because we have a resample curve based by length. So the length is a static value. Whole edge I did with the value of the height of the spiral and multiply by 2. This is a static number, and I don't know why Blender makes this strange effect. So if you know why, please leave a comment. So to avoid this behavior, we can simply snap the curve height based by this little height. So we can link these to the snap mathematical function and use this single length or height, this piece of height, to have a correct value here. So I can move this a little bit, snap, combine, and use this as the z factor, resample the curve and instance as we want. And now if I decrease, we have a correct number of pieces shown. Select all these node, Ctrl J, F2, instance pieces, and now next step, we need to create the mirror part of this shape, but in this direction. So we have to transform this geometry, rotate this by 180 degrees. You can see the result is this. So I want to shift these here and here to link each other, so I can join them to see the result. So I can see that I want to have this behavior like this, and to do this I want to use another group input node, use the whole edge value with a combine y value, transform, link these to the translation, and the start point is correct, is here, but the z component is wrong. So I have to use this height described before, so the height of the spiral and the height of this segment. I can use these to shift vertically. I can use these to make it more readable. This is my shape. We can select these, Ctrl J, merge parts, single curve. Then, before going to the next step, we forgot to analyze not this axis but the x-axis. So if I rotate this view, you can see that we have to shift this line here and this line here to make this link possible. So if I press 1, I can see this shape, and I have to manipulate what? The linear part. So I have to increase the x value here and here with the same value by what? By the radius itself, because we have the radius here. This is the radius of our spiral, so this is the exact distance we want to shift the linear curve. So I can link radius directly to the x value, shift right, drag, G to move, and drag this to the x value to both of the start and end point of the linear part of the curve. And now we have the correct position of the linear part, and you can see if I rotate the shape, we have the correct link of this curve and this curve to the other part of the spiral, thanks to this merge parts single curve section. Now I could add a curve to mesh node, but there is a problem about the mesh. So if I create a circle curve directly in this point and decrease the radius 0.003, you can see this strange behavior. So you can see this particular effect. Why? Because we don't have a single curve, we have many curves, so we need to create a single curve to make a correct curved mesh profile. To do this, I have to add curve to mesh alone. Then you can see if I press Shift, Ctrl and click, in the spreadsheet we have 10 instances of geometry. So we need to realize the instances, Ctrl, Shift and click, to have an entire list of vertex. So in this case I can use the merge by distance node with a little value and then convert again the mesh to curve. Now I have one spline with all the control points, but this is one piece, one curve. So Ctrl J, F2, prepare profile curve. Now next step, we need to instance this curve shifting to this line. So we have to add a new line to the y direction, so 1 and 0. I can use another group input node and a combine xyz value to have the correct end value here. We want the y value, so I need to instance on point on this curve this instance, Shift, Alt and click to show this part. So if I increase this value of y, we have this behavior, but we need to resample the curve. How many times? We need to use the length as before, and we will use the whole edge as the length, but we need another value for the y, so we can use these, go up and rename it in length from 0 to 100, for example. Set these more and more, but you can see the same bad behavior as before for the vertical line. So we need to snap it by the whole edge, so we can use the snap node, link here and increment these by this value. Now we want to have this curve rotated by the z-axis here in the middle to have this point go here and then here and then here and so on. So to do this I need to create a node rotate instance. I have to use index linked to the module to have an alternate selection or alternate mask. So every 2 index, so 0, 1, 0, 1, 0, 1. And for this tutorial I don't use the approach of a map range, but this example. So multiply by your value 180 degrees, so I have to convert to radians because I will use a combine xyz vector node with the z axis and link these to rotation. So this rotation is used with degrees, so these are degrees, but if you pass through this node you have automatic radiant information. So if I increase these, you can see a complete round after 2 multiplied by pi. So this speaks in radiant language, so we have to convert our degrees in radiant. So we can link these and have this behavior, but we have to shift this curve a little bit. If I increase this pivot point, we have these. We need to adjust this value, leave this check for the local space because we want each instance have the own pivot point and not a global point. So we can use the group input and use the whole edge to the combine y value of the combine xyz because we want to shift in this direction. Link these to the pivot point, but we have twice distance of this hollow edge, so we have to add a math operation that divide this whole edge by 2. and ta-da! This is our result. So we can select all these nodes, Ctrl J, F2, mirror, curve. Now we have these, they are all curves, and now we need to create a profile curve. So curve to mesh, circle, mesh, alt right button and drag, fill caps, and use the group input radius for the radius and the same resolution for the entire other parts of the shape. So this is the profile curve. Ctrl J, F2, profile curve. We can assign set material. We can create a simple metal material, set 0.05 to the roughness, metal to 1, select the material here, show the previous material, and this is the result. So this is the final graph. It's a bit big, but this is correct. And in the layout we can play with the values that we have these here with the little round. You can see a little round. You can decrease the whole edge, so we can have these. For example, we can increase the radius without lose information or have collision between the curves. So with the Shift Z you can see better the result, and you can increase or decrease the height. So 0.02 millimeter is a good result. Voltage 0.025, and you can increase or decrease height and length. This is the tutorial. Thank you guys for watching this video. I hope you like it. If you want to leave a comment, I will appreciate it. Check a like if you want, and if you have subscribed to my channel, make sure to check the bell icon to get all the notifications about new posted videos. You can download this project from my Gumroad page, link in the description, or you can make this workflow on your own. At the end of this series, I'll add an additional link to let you download all the bundle of this project always from the Gumroad page. See you soon to the next video of this series. Bye!